Okay, introduction to networks skills-based assessment. Okay, CCNA 1. Given an IP address and mask 192.168.100.0.24, design IP address scheme that satisfies the following requirements: subnet A 55 hosts, subnet B 28 hosts. Okay, 192.168.100.0.24. okay, 192 decimal, 168 decimal, 100 in binary, in binary, 64 plus 32 plus 4, 100. Zero in binary. Okay, 55 hosts. The number of hosts 55. So the subnet mask just here. Copy this and fill this. Okay, this is the network address. One 26. Okay, the serial subnet is used. Okay, 192, 168, 100, 0, 8, 16, 24, 25, 26 bits. Okay, the first IP address, one IP address next to the network address. This is the broadcast. (163). Okay. Okay, 3, 7, 15, 31, 63. And the last IP address is one IP address before broadcast. Okay, the next IP address one 0 0 0 0 0. Okay, 28 host just here. So this is the subnet mask. Copy this and fill with number ones. Okay, this is the network and this is the broadcast. 192, 168, 100, 64, 27. Okay, 164, 8, 16, 24, 25, 26, 27. this is the network, and first IP address, the next to the network, broadcast, and 95. Okay, broadcast 164 plus 31, 95. Okay, 64 plus 31 is 95. So the last IP address is one IP address before broadcast, and now it's ready. Okay. Fill the spaces in the document. Number of bits in the subnet. Okay, so only use the 24. Okay, and use 26 on subnet A. So 26 minus 24, 26 minus 24 is 2. Okay, 2. IP subnet mask in binary, 26 bits. Okay, 32 bits, 26 the subnet mask, and 6 the bits for hosts. Okay, decimal 192. Okay, this is 192. Maximum number of usable subnets. Okay, use this. So two. Four hosts per subnet. Okay, okay, 6 bits for hosts, so 2. Six minus 2. Okay, 62. Okay, remember maximum number of subnets 4, because 2 power 2 bits for hosts. Okay, 2 bits for hosts, 2 bits for hosts. 26 minus 24, 2 bits for hosts. Okay, and maximum number of hosts per subnet. Use the 6 bits for hosts, 6 bits for host minus 2, okay, minus the network and the broadcast, okay, 62. IP, this is the IP for the network. Fields, fields, fields is 1, last 62, broadcast 63, last 62, broadcast 63, okay. Subnet B, number of bits in the subnet B, 3, only use 27 minus 24, okay, 27 minus 24, 3, the subnet. IP subnet mask binary, okay, 27 bits for subnet mask, 27 bits for subnet mask, 27, and 5 bits for hosts, okay, and decimal, okay, this is 224, okay, number of usable subnets, okay, the 3 bits for subnet, eight, number of usable hosts per subnet, use the 5 bits for hosts, minus 2, 30, the network address, this, fields 65, broadcast 95, last 94, last IP address 94, broadcast 95, ready. Host computers will use the last IP in the subnet. The network router will use the field's IP host. The switch will use the second IP. Okay, so PCA is placed on subnet A and PCB is placed on subnet B. Okay, and gigabit 0 is placed on subnet A and gigabit 1 is placed on subnet B. S1 is placed on subnet B. PCA last IP address, this 62. Subnet mask, okay. Gateway is the gigabit 0 on R1, so for subnet A is 1. Okay. Gigabit 0 first IP address, PCA last IP address. Gigabit 0 first IP address, PCA last IP address. The same subnet mask. Okay. Gigabit 1 R1 placed in subnet B first IP address 65. Subnet mask 27. Okay. S1 the second IP address. The second IP address is 66. Same subnet mask for R1, S1 and PCB. So PCB use the last IP address 94, and gigabit 1 is its default gateway. Okay. And PCB last IP address on subnet B, gigabit 1 on R1 first IP address on subnet B, S1 second IP address on subnet B. Okay. You can add to the default gateway S1. Okay. Erase startup config file on the router, reload the router, enable erase okay, reset activity. Okay. Okay, erase startup config file on the router, reload the router, enable erase startup config, enter, reload, erase startup config file on the switch, delete the VLAN file on the switch, reload the switch, enable erase startup config, enter, delete VLAN enter, reload. Okay. Next. Document. Configure host computers, PCA, okay. Okay, the subnet mask. Okay. ipconfig space /all. Okay. physical address, IP, subnet mask, default gateway, PCB, ipconfig space/all, physical address or MAC address, IP address, default gateway, ready. Configure 1, configure 1, now enable configure terminal. Okay, disable DNS lookup, no IP domain lookup, router name R1, host name R1, minimum length for passwords 8, passwords mean security, passwords mean length 8, enable secret password, enable secret pass 1, console access password, line console 0, password com pass 1, login, telnet, line bty 0 to 15, password bty pass 1, login, banner message of the day, okay. Interface gigabit 0, description, IP address, fields, activate interface, no shutdown, okay, gigabit 1, description, connection to S1, IP address, (65) to 24, 65, no shutdown, configure S1, enable configure terminal, hostname S1, management interface on VLAN 1, interface VLAN 1, IP address, okay, subnet mask, enable the interface, activate the interface, no shutdown, so enable secret password, exit, enable secret pass1, console line console 0 password, okay, login bty line bty 0 to 15 password, okay, login the default gateway, exit, IP default gateway, okay, verify, verifica, verify, ping to R1 gigabit 0, successful, okay, switch VLAN 1 on switch 1 66, okay, repeat, successful, PCB 94, successful, repeat, successful, gigabit 1 on R1 65, successful, switch from PCB, gigabit 1 on R1, ping from PCB to R1 and gigabit 1 on R1 65, successful, to switch successful, repeat, successful, okay. What other command is useful in displaying network delay and breaks in the path to the destination? Tracert, okay. IPv6 addressing, IPv6 addressing, given the IPv6 network address. Okay, configure IPv6 addresses for gigabit interfaces on R1. Use this address as the link local address on both interfaces. Okay, and gigabit 0 fields in the subnet A. Okay, gigabit 0 fields on subnet A. Okay, link local. Gigabit 1 fields in subnet B. Link local. Enable IPv6 unicast routing. IPv6 unicast routing. Okay. Okay, so configure this router. Okay, interface gigabit 0, IPv6 address. Okay, link local. Gigabit 1. Okay, link local. Exit IPv6 unicast routing. Ready. Use autoconfig to automatically assign the PCA's IPv6 addresses. PCA autoconfig. Okay. IPv6 config all. The gateway is the link local on R1. Okay, PCB autoconfig IPv6 config IPv6 config all. Okay, from PCA ping successful. Successful. Through PCB. Okay, the default gateway is missing. Okay, now gateway is ready. Repeat, successful. From PCB. Successful. Successful. L1 and show version. Router model. Okay. iOS image. Total RAM. Total flash. Configuration register. Okay. What command was used? Show version. Okay. Display a summary of important information about the interfaces on R1. Show IP interface brief. Okay. IPv4 routing table, IP route. Show IP route. Show IP route. Layer 2 to layer 3 mapping. Show ARP. Detailed IPv4 information about interface gigabit 0 on R1. Show interface gigabit 0. Show interface gigabit 0. IPv6 routing table. Show IPv6 route. Summary of IPv6 interface addresses. Show IPv6 interface brief. Display information about devices connected to R1. Information should include device ID, local interface, hold time, capabilities, platform, port ID. Show CDP network. Okay. Save the current configuration. Copy running config to startup config. Enter. Ready. pass1 enable sec pass1 copy running config to startup config. Okay, muchas gracias, thank you very much.